Hi guys, so we're going to go over this slide 4, on your student practice. Now this student practice was given to you in class, and I want to go over this. This one seemed to be the most challenging to work through, and a lot of questions were posed about this, which I'm very grateful for. And this is where we're moving on in the future for Unit 3 into Unit 4, is really looking at linear function rules. We're going to solve them by knowing X and Y values. We're going to graph those. We're really going to study these equations. And therefore, that's why I want you to be able to identify them before we can actually study them. What is considered a linear function equation and what is not considered linear? So remembering from our notes, I'm going to shut myself down there. So remembering from our notes, if you remember correctly, we have the equation y equals mx plus b is what all linear equations need to be in the form. What are the key elements of this? The key element is that you have an x value that has a power, an exponent of 1. Most often, like when you're looking through here, if that x value has an exponent of 1, it's not shown. So that's why most often you'll see that there just is, in a linear equation, an x, but that is an x to the exponent of 1. So that x needs to be to the first power. That's a major rule. If you can see that that x is to any other exponent other than 1, it automatically is not considered a linear function equation. The x, since it is a variable, sometimes you'll see a coefficient of x. Remember, a coefficient of x is a numerical value that's multiplied to our variable. That's what makes our coefficient. And it has a constant term, a positive plus a number or minus a number. And we're going to discover what these values of the m and b actually represent, and we'll move from there. So our job right now is to take each one of these 8 equations and see if it fits in the mold. Now remember, we talked about commutative property as well, that when we see a 3 plus 4x, we know that that's the exact same thing as writing 4x plus 3. We need to validate that the x is to the exponent of 1 and that we have no other x terms to the power of 1. And we might have a coefficient, and we might have a constant term in there. So looking at number 1, I can see y equals, this value is a constant, therefore it's representing the b. And then this value is an x to the exponent of 1. And this happens to be the m. So in this case, it's a b plus mx. And since we know the commutative property and it's a works and it's balanced, we know that yes, this is a linear function. It fits the mold. It has an m times an x to the power of 1, and it happens to have a constant term there as well. Here is one that we talked about, and we talked about this many times, because it doesn't look like it should belong to the linear family, but it does. So in this case, if I'm trying to model that y equals mx plus b, I can only see that this -7 is my constant value. So that -7 represents the b. So where is that missing mx value? Well, when we simplify equations, when would an mx be simplified to the point of not existing? And that would imply that the coefficient of the x to the exponent of 1 is 0. When we're simplifying something, is y equals 0x minus 7. This is an unsimplified equation where we would not represent the coefficient of x representing a 0. Since 0 times any number is 0, we would replace this with a 0 in our first step of simplification. And then we wouldn't leave this either, because 0 minus 7 simplifies to y equals -7. So originally, this equation did and does actually follow the y equals mx plus b, but through simplification, it lost some of its easy terms to classify. So when we have a value that's y equals just a constant term, y equals b, or we could have that commutative read it the other way, b equals y, which is acceptable. If we have equations that are in this format, that the y is equal to a constant term, that identifies that the m is 0, and it is still a linear equation, and it does fit that linear guidelines of equation. Those are the tricky ones. Those are the ones that don't fit beautifully into that y equals mx plus b. The third one here, you can clearly see that that x value is not to the power of 1. Therefore, this term and this full equation is not linear. Moving on, that x, which we talked about in our notes, that x cannot be in an exponential location. It belongs to a different family, one of those families that you will study in high school. So therefore, no, this is not considered linear since the x is actually representing an exponent. Moving down here, my x is in the denominator, which is different because my linear equation has an x in the numerator. So if I rewrote this equation to have that x in the numerator, this is when my unit 2 skills come in. So if my denominator is x to the power of 1 and I want that denominator to jump up into the numerator, hopefully you remember that x would be to the negative 1 in the numerator. So this equation unsimplified would be 3x to the negative 1. Now, since linear equations have to have x values to the exponent of 1, and this one with the x in the numerator is to the negative 1, this verifies that this equation is not linear. Now, again, that takes a little bit of understanding from our Unit 2 skills. So hopefully when you watched that and heard that, you'd be like, oh, that's what I missed. Moving on here, this one looks like y equals, my m just happens to be a fraction. I have my x, it is to the exponent of 1, but I'm missing that b value. So is this still okay to be missing a b value? And we talked about this, and hopefully you remember, sure, that b value could actually be represented by a 0. In our simplification, we would never show in a simplified equation a plus 0 constant term. We would eliminate that from a simplified equation, but that does not mean that is not represented in a linear equation. So this case, when we have a y equals an mx, but I don't see a constant term, or again, if we see an mx equals y, that still is representing a linear equation just with a b value of 0. So that is still in consideration y equals mx plus b form. Moving on here, hopefully you can identify right away that that x value has an exponent of 3, not allowed to be linear. You need the exponent of 1, automatically not a linear equation. And my last one, y equals, I can see that x value is to a 1, which looks positive. This m, it does have a coefficient, and it does have a b term. It just happens to be that that b term is negative. It's a negative 4. But that looks great. That looks like the perfect mold of a linear equation. And yes, that is a linear equation. So again, these explanations underneath that I asked you to do, I want those in your words. It doesn't have to be mathematically perfect. I just need to have a sense of you understanding in this equation y equals negative 7 that the m is represented by a 0 and that this equation is still considered linear. In this case, that b term is represented by 0, but this equation is still considered linear. And that we do have the commutative property allowed when we're writing linear equations. And this still is, maybe it's not in proper form, but it's still considered a linear equation. So hopefully that video helps you again hear and see why some equations do fit the linear mold and others do not. Remember, I want you to listen to this as many times as you need. Ask me any questions. Send me some private comments in Google Classroom or an email. I'm happy to help. Ask in class. We're going to go over this first thing tomorrow morning. See you all then. Bye.